Welcome to Curie Electronics. Today we will solve SDSC SHAR previous year Technician B Electronics question paper. First 30 questions out of total 60 questions. I am not so sure this question is 2019 or 2017. It was sent by one of my friend, so he is also not sure about it. Anyway, it's a recent question paper. Okay, let's start the questions. Question number 1. The maximum efficiency of a half-wave rectifier is? What is the maximum efficiency of a half-wave rectifier? The answer is option A, 40.6%. And what is this 81.2%? It is for full wave rectifier. Full wave rectifier. Now can you relate this 25% efficiency to anything? This is for a class A amplifier. Maximum efficiency of a class A amplifier. What about this 50%? It is the maximum efficiency of a class A transformer coupled amplifier. Right? Not the difference. Transformer coupled amplifier. Coupled amplifier. A power supply A delivers 10 volt DC with a ripple of 0.5 volt RMS, while the output supply B delivers 25 volts with a ripple of 0.5 volt RMS. Which is better power supply? Which is better power supply? It is with 25 volt. See, one is giving 25 volt, 0.5 volt RMS ripple. And the other is giving 10 volt, 0.5 volt ripple. RMS, I am not writing RMS, ripple. So, which is better power supply? This first one, the 25 volt, 0.5 volt. One is the better one. So in the option, while power supply B is the right answer. Power supply B is the right answer. Because see, it is at a higher voltage and the ripple is same. Ripple is same for both the power supply. One is at lower voltage. So ripple means what? On the DC voltage there is something AC component. So the better power supply is the 25 volt, 0.5 volt RMS ripple. The input of a step down transformer is 240 volt RMS. Okay, the input. The turns ratio of transformer is 8:1. What is the peak voltage at the secondary of the transformer? Okay, so he has given, what he has given? E1 equal to 240 volt RMS. Turns ratio he has given NP upon N secondary. Turns ratio has given us 8:1. And he told step down transformer. So what we have to find? We have to find what is the peak voltage at the transformer. So write the transformer turns ratio equation. N1 upon N2 equals E1 upon E2. So what is N1? N1 equal to 8. What is N2? N2 equals to 1. What about the E1? E1 equal to 240 volt RMS. E2 we have to find out. So E2 equals, if you cross multiply, what happens? 240 volt RMS divided by 8. So what is the volt? You will get 30 volt. 30 volt, what is 30 volt? This is the RMS value, okay? This is the RMS value. If you want to convert RMS value to, he's asking peak voltage. V peak voltage. So what do? You have to multiply by root 2. Root 2 multiplied by 30 volt. What do you get? We should get 42.5 volt. Okay. So what you should know to solve this question? You should have an idea about the transformer turns ratio. Also, conversion of RMS voltage to peak voltage. So we are not ticked the answer. What is the answer here? Answer is option D, 42.5 volt. Next question. In the breakdown region, a Zener diode behaves like a dash source. So what is the characteristics of a Zener diode? Not a straight line, that is okay. Okay, we have, what is this? Is a current, Zener current, and this is the 4 volt voltage, and this is the reverse voltage of a Zener diode. So in the forward direction, it is exactly like a normal diode. The reverse direction, what happens? Here the Zener breakdown happens. So if we see here, the current is increasing here. See, this current is increasing. What about the voltage? This is the voltage. See, the voltage is remaining constant in the normal breakdown voltage of the Zener. The voltage is remaining here, voltage constant. Voltage constant, right? So what is the answer? Answer is option A, constant voltage. Constant voltage. Next question. A gain of 1 followed by 6 zeros times in power is expressed by. Okay, we have a gain, we have AV. I'll write it on the top, this question, AV. So that is given as 1 followed by 6 zeros. So this is equal to 10 to the power 6. But we have to express it in dB. So what is the equation for power? Power in dB. Power in dB equals 10 times a log 10 of log to the base 10. Okay, not E. It is a log to the base 10. 10 to the power 6. Which is equal to what? 10 multiplied by what is 10 to the power 6 log? It is equal to, how do you write? In a logarithm, what we can do, we can apply log property here. I'll write it down, which equals, I'll write it here, 10 multiplied by 6, I will take it out. It is from the log property. Then what is left is log 10. What is log 10 to the base log 10? That is equal to 1. So 10 multiplied by 6 multiplied by 1. So we will get 60 dB is the answer. 60 dB is the answer. So the answer is 60 dB. Next, question number 6. For highest power gain, one would use dash configuration. For an amplifier, normally we use CE configuration, because CE configuration gives power gain. That is, we will get current gain as well as the voltage gain. A 2-transistor class B power amplifier is commonly called dash amplifier. It's commonly called as push-pull amplifier. Push-pull amplifier. when what turns ratio NP upon NS, what turns ratio is required to match 4 ohm speaker to a transistor having output impedance of 8000 ohm. Okay, because see we assume that this is a transistor circuit, and we have to drive this to a speaker. Okay, this transistor is output is going to be connected to the speaker. So this speaker is having all resistance of 4 ohm. What is the transistor section resistance? That is 8000 ohms. Now in between we will use a transformer here. We are going to use a transformer here for the impedance matching. Okay. Impedance at primary upon impedance at secondary. So here there is a square term. This also can be written as n square. Okay, n square. So make note of this equation. It needed some. It is there in many question papers. This equation. Whenever we want the impedance matching through a transformer, we have to use this equation. So now NP upon NS we have to find. So NP upon NS whole square equals what he has given. What is the NP? What is NP? This is the transistor is the primary for the transformer. That is 8000 upon 4 is the NS. So if you simplify what it comes, 2000. So NP upon NS square equals, we got 2000. If we take, now we want the ratio of NP upon NS, right? So we will take, what we will take? We will take square root of 2000. This is the answer. So how can we write it? We can write it as square root of 100 multiplied by square root of 20. Square root of 100 we know it's 20. It is 10, sorry, 10. What about square root of 20? It should come 4 point something we know. 4 point something should come. So the answer is 44.7 is the answer. 44.7 is the answer. The gain of an amplifier with feedback is known as, it's a closed loop. When feedback comes in a circuit, it's a closed loop circuit. Double tuned circuits are used in DAS stage of a radio receiver. This is used in the IF stage. The IF stage of it. The question is, listen, this may not be so clear. Double tuned circuits are used in DAS stages of a radio receiver. It is the IF stage of a transformer. Okay, we'll go to the next question. Demodulation is done in. Where is the demodulation is done? Demodulation is related to the reception of a signal. That is done in the radio receiver. Answer is radio receiver, not in transmitter, not in receiving antenna. It is the radio receiver part. Demodulation. After IF, this demodulation comes. So demodulation is done in radio receiver. In TV transmission, sound signal is dash modulator. What is the answer? It's a frequency modulator. Certain voltage regulator has no load voltage of 6 volt. V no load voltage equal to 6 volt. And a full load V full load voltage of 5.82 volt. What is the load regulation? Load regulation is the question. Load regulation. So load regulation. It is a voltage regulators, volt regulator. load regulation, that is equal to V no load minus V full load upon V full load. This is the equation. So this equation you should know. See, this is for what? This is for voltage regulator. Okay, if it is for a transformer, there is a difference. Then in the denominator it is V no load. Okay, in the case of a transformer. So let's solve it. So if we put the values, we got 6 minus 5.82 upon, what is the full load? 5.82. If we simplify this, what we get? Okay, we have to multiply by 100. Okay, it's a full 100. I forgot. 100. We have to multiply by 100. So you will get 3.09%. So the answer is option A is the right answer. Option A is the right answer. 3.09. See, but there is one more case is there. If it is a transformer voltage regulation, then the equation is different. What is the equation? Load regulation in percentage equal to V no load minus V full load upon V no load multiplied by 100. This is for what? This is for transformer. For a voltage regulator, the denominator it is VFL, full load voltage. So make note of it. Next question. Dash multivibrator is a square wave oscillator. It's a stable multivibrator is a square wave oscillator. This monostable, it gives one pulse like this. This is also known as single shot or monostable. Bistable means it has got two states, just like a flip-flop. The resistance of an ideal voltmeter is, what is the answer? Resistance of an ideal voltmeter is, it has to be, we are going to measure the voltage of a sensitive circuit. So it should not draw any current from the circuit. That's what we wanted. So it has to be infinite. The resistance of an ideal voltmeter is infinite. But when it comes to voltage source, what it is? It has to be, for a voltage source, ideally it has to be 0. Question number 16. The output of a particular op-amp increases 8 volt in 12 microseconds. Slew rate. See, slew rate. Slew rate is the change of output of a op-amp with respect to changes in the input. It is volt. Slew rate is given as volt per microsecond. So now what he has given? He has given 8 volt changes in 12 microseconds. We are interested what is the change in 1 volt. What is the change happens in 1 microsecond? That's what we want to know. So what we will do? We will divide both by 4. We can divide both by 8 divided by 12. What we will get? That is the answer. So if I divide by 4, I will get 2 by 6. 2 by 3. Yeah. 2 by 2 volt. In the numerator we want, the denominator we want 1. So now again I will divide numerator and denominator by 3. Or else you simply divide 2 by 3. 2 by 3 will give what? It will come to 0.67. Let me check once. Yeah, you will get 0.67 volt per microseconds. So the answer is 0.67 microseconds. That is the answer. These questions are not so clear because I got the photo like. Okay, next question. A certain non-inverting amplifier. Non-inverting amplifier. We will say non-inverting, inverting mainly in the case of what? Op amps. Has Ri 1 kilo ohm and Rf 100 kilo ohms. The closed loop voltage gain is. So it's a non-inverting amplifier. This is our inverting input. This is our Ri. This is what? Ri. And this is Rf. And this is the non-inverting terminal. We are applying the signal. Now what is the output? Vout is given as 1 plus Rf upon Ri multiplied by what? Vin. Here in this question we have to find out only this part. What is the closed loop voltage gain? This is the closed loop voltage gain factor. So let's calculate 1 plus Rf upon Ri is equal to 1 plus what is 100 kilo ohm upon 1 kilo ohm. So we will get 100 upon 1. So it is 1 plus 100. So what is the answer? 101. 101 is the voltage gain. Option C is the right answer. A voltage follower. A voltage follower has a voltage gain of 1. That is right. Is non-inverting. If you see the voltage is non-inverting also. Has no feedback resistor. Correct. So the answer is option D. Has all the above. Correct. The voltage follower looks like this. To the positive we are giving in the input Vin. The negative feedback is the voltage follower. Question number 19. The disadvantage of voltage divider bias is that it has. The answer is it has many resistors. For a simple voltage divider there will be 2 resistors, but we can make a number of the voltages with number of resistors. The single stage transformer amplifier with collector load RC and emitter resistance RE has a DC load of. It is RC plus RE is the right answer. How? See, if you have a C amplifier, simple C amplifier. Okay, this is a simple C amplifier. I'm not drawing complete. Now, if you want to find IC equal to VC upon, this is the RC resistor. VC upon, this is a VCC. VCC upon RC will do. But if the circuit is like this, how? We have a collector resistor RC and a emitter resistor RE. Then we have a base resistor. Then the remaining everything is same, VCC. Now if you want to find IC, what is the equation? VCC upon RC plus RE. RC plus RE. Okay. So the answer is RC plus RE. Question number 21. In a transistor amplifier, we use that transformer for impedance matching. What is the answer? We will use a step down transformer. Why? Why it is step down? Because always, see, assume we are driving a speaker. Speaker will have ohms, 4 ohm or 8 ohm impedance. But the transistor stages will have hundreds of ohms. So we need a step down transformer. Dash coupling is generally employed in power amplifiers. power amplifiers we use transformer coupling. The basic purpose of applying negative voltage feedback is to reduce the distortion. Our voltage gain decreases, but distortion reduces. When the outermost orbit of an atom has exactly 4 valence electrons, correct? 4 valence electrons. What is the main property of this semiconductor materials? It will have 4 valence electrons. 4 valence electrons. Then the material is semiconductor. So the answer is option A. Option C, semiconductor. Okay, I think it's not visible properly. Semiconductor. Maximum power will be transferred from a source of 10 ohm resistance to a load of. Whenever the source resistance matches the load resistance, maximum power is transformed. So the answer is, it is directly coming from a theoretical question. So 10 ohm. A lead acid battery fitted in a truck develops a 24 volts and has an internal resistance of 0.01 ohm. So internal resistance is given as 0.01 ohm and the battery voltage is V equal to 24 volt. And the load is 100 watt headlight. What is the voltage drop in the internal resistance? So we have a 24 volt battery. There's an internal resistance of 0.01 and the terminals we are connecting, we are having a, let's take it as a resistance only. We are having a load and there 100 watt is getting dissipated. What is the equation for power? Power equal to I square R or V square by R or V into I. Now, which equation we will use here? We know, okay. V into I we will use. Power equal to V into I. So, P equal to voltage into current. Now, when load is not there, what is the voltage? That is 24 volt. Voltage he has given us 100 watt. And I, what is current I? I comes to, I equals to, we'll get 4.167. Okay. Now, voltage, current we know. Now, when current flows, what is the drop? When so much current flows through the circuit, what is the drop across this 0.01 internal resistance? Here, so V equal to, what we have to find the I into R. What is the I? 4.167 voltage is flowing through the internal resistance. What is the ohm? 0.01. Which is going to be 0.04. So the answer is, what is the answer? .04 will come. Because 0 is a 0.04. Option B is the right answer because you are multiplying by 0.01. Multiply, just take 4 only. If you multiply, what you will get? We will get 0.04 we will get. So that is the answer. Option B is the answer. Question number 27. The leakage current in a PN junction is the order of, it is in microamps. It is in microamps. The leakage current in a PN junction is of the order of microamps. Question number 28. The device associated with voltage controlled capacitance is a, that is All of us knows Weyerhaeuser diode. How do you draw the characteristic curve of a Weyerhaeuser diode? Let be the capacitance. This is the capacitance in PF, and this is the reverse voltage. Reverse voltage. Minus 5 volt, minus 10 volt, minus 15 volt, up to minus 15 volt. I will take it. You will get a curve like this. That means what? When the reverse voltage increases, our capacitance is decreasing. Is the Weyerhaeuser diode. What happens when reverse voltage increases? The capacitance decreases. That is the Weyerhaeuser diode. What is the series resistor required to limit the current to 20 milliamps through a LED with voltage drop of 1.6 volt when connected to a 10 volt supply? So we have a supply. What is that supply? 10 volt. In the resistor, for a LED to, this is the resistor to limit the current. Then we have a LED and the circuit is closed. LED is a light emitting diode. So what is the cut-in voltage of this LED? That is given as 1.6 volt. 1.6 volt is the cut-in voltage of this particular LED. And now if you want to calculate R equal to what? The resistor is connected between 10 volt and 1.6 volt is the voltage drop. So 10 volt minus 1.6 volt upon current. What is the current flowing through the circuit? Current required for the LED. The LED requires 20 milliamps. 20 milliamps upon 20. So what is the voltage? 10 volt minus 1.6 volt. What we will get? We will get 8.4. 8.4 volt upon 20. How do you simplify? So R equals 8.4. If I divide by 10, how can I solve this? Simply the denominator I'll write it as 10 multiplied by 2. So I will get 0.84 by 2. 0.42. 0.42. This value is in kilo ohms. See, whenever I solve this voltage, current and voltage in volts, I will always take, okay? And current I will take it always in milliamps. And resistance I will always take it in kilo ohms. So I won't write it. So whatever value I got now is in kilo ohms. So we will convert it to ohms. So 0.42 multiplied by 1000. So I'll get 420 ohm resistor. So the answer is option B is the right answer, 420 ohm. This is the question number 30. This is the last question. No, this not this question. One more question. Okay. Okay, I missed one question. I think this is the question number 29. Okay, so 29. So up to 29 questions we have solved in this part 1 questions. In the next part we will solve the remaining 31 questions. I hope these videos are useful to you. So if you like the videos, don't forget to hit the like button. Also share with your friends. And SHAR question papers are not available easily. See you soon with the next part.